Let's have a look. So we're saying practice 1, page 105. I think not so easy when I can't see the thing. All right, so what we're looking at is goes too quickly. Okay. So we're looking at this table, right? And we want to calculate the measures of central tendency from it. Let's talk about doing that. All right. So, what does it mean first? The table shows the heights of a group of students on their 14th birthday. So interpret that.
So within the height area, it shows for example, the first one is 1.20 is smaller than x, but that's smaller than 1.3, meaning that any data that's between that's in the first box is between 1.2 and 1.3.
Yeah, how many people are between 1.2 and 1.3 meters tall, Aidan? 4. How many people in total, Steph? Yeah. How do you know? You added them up, yeah? So if we add up the frequency, we think it's 30. Quite often I ask that question, it says it in the question. There are 30 students, and we go, I'll add them up. So I'll read the question first, so I'm just be sure. All right, so let's have a quick look then. So we know that's this people, this. So the thing about grouped data that hopefully you read yesterday, we've got less detail, yeah, less information. Why, Owen? Yeah, so we don't know how tall these 8 people are, do we? We've grouped that data. We know they're somewhere. Why do you reckon they've done that for this data?
Maybe because if you had to go too exact, it would be too, if you went to their exact heights, it would be too detailed.
Yeah, we just don't need that detail, do we? Yeah. That's the thing. We've kind of decided, well, I'm just interested in 10 centimetre things, and I've got enough information now. I don't need to know to the nearest half a centimetre how tall everyone is. I'm grouping it. Why might I be interested to know about heights at all? Why are we collecting this data? Cameron? Yeah, for what purpose?
Maybe it's for clothing.
Could be clothing, yeah. Could be a school working out how tall desks should be. Yeah. Could be anything like that. We don't know. I'm asking you to have a guess, really, an educated guess. So let's talk about this. So what would be the modal class? What's the modal class? I mean, it should be an answer just super quick like that, unless you don't want modal class. What modal class is the same thing as what, guys? Mode. Just asking for the mode. But remember I said modal class is just different vocabulary because it's not raw data. Yeah, so I'm asking you, when I say modal class, I'm asking for the class interval with the most in it. And which one's that?
1.1 and 1.5.
Thanks, Cameron. Your voice went a bit higher than normal, but yes, the modal class is 140 to 150. Okay. Find the class interval that contains the median. How do you do that? Yeah.
You take all of the entire number of students, plus 1, divide by 2, and then you find where that number fits inside the column
Yeah.
we can see.
So there's 30 students. The middle number, the middle student is not the 15th one, is it?
No.
Because when that people made that mistake, they divide by 2 and they say it's 15. But that means there are 2 groups of 15. So the middle is actually halfway between that group. So for the median, okay, what I actually want, I need the 15.5th student. So what I actually want is the 15th and the 16th student, and I want to know what's halfway between, right? But when I've got grouped data, really, I can only just find the 15th and 16th. If they're in the same group, it's easy, and normally they will be, all right? Sometimes you're unlucky and you know that the 15th is in one group and the 16th is in the next group, and then you've got an issue to sort out. But normally we'll find they're in the same group. So I don't know whether they've done this in the book, but quite often what we can do is start ourselves off with what's called a cumulative frequency, and that helps us find the middle. So group 1 has 4 students, group 2 has 6. How many have we got in total? 10, then we've got 18, then we've got 24, and then we've got 30. So by doing the cumulative frequency, it's really easy now to find where the 15th and 16th must be, because there's 10 in that group, so then there's 18 in that group, so the 15th and 16th must have fallen in that group as well. So the median student will be, again, in the same group, which is hopefully what we're getting at. All right. Now, trying to move on a bit quicker than is in the book, I'm also going to use this example because you guys can cope. Well, actually, you're all right with that, right? Yeah, that's easy. Super easy. Some people struggle, but I think you're good with that. Right? How could I find the mean of this data? So this is kind of the more complex. I want to know the mean of the data. Right? So you haven't got that far yet? No? That's kind of the next stage. That's where I hoped you'd be. Aidan. Yeah, it makes sense. You add up the numbers and you divide by the number of numbers, yeah? It's not going to change. Just because the situation changes, the mean is still add them up. Right, so we're going to recognise that symbol, the sum of, add up all the x values, and then divide by the sum of the frequencies. Okay, so that's all right. What's the sum of the frequency? 30. So now we've just got to add up all the numbers. Any issues you can see there? Yeah.
Since it's a range for each one, you have to get the median of each range
Okay.
to use for.
The problem, I think Cameron said, before Jack solved it, was that you don't have the numbers, do you? We've said that before. We don't know the actual numbers, so we can't add up the numbers. So what we do is we try and eliminate as much error as possible. Liam?
I thought you had to assume that it was the
Well,
greatest value.
No, we don't do that. When we calculate a mean, we actually estimate the mean of group data. It's an estimate because we don't know. Now, Liam, what you said was we take the top value, yeah? We assume
No, I
it's...
say we take, in each section, we take like 1.3 and then 1.4 and then 1.5 and then 1.
That's what I said, you take the top value of each class integral.
Yeah.
Now, that would make some sense, but I kind of said, I'm going to try and eliminate as much error as I can. Do you remember the word error? Error is how far away from the real number, your solution is. So error doesn't mean you've done anything wrong. Error means how far away from the actual answer your correct procedure has got you. Now, the best way to eliminate the error is to not assume all the numbers are at the top end, but to do what Jacques said, which is to assume all the numbers are in the middle. Why is the middle better than the taking the top end? Can you think, Liam?
Maybe because it's a lot closer. Cause
We don't know the numbers, so we can't say it's
I know,
close.
but I'm just saying, like theoretically, it makes a lot more sense to assume that they're near the middle.
But
than
why?
they are near
How
the
does it
top.
help us eliminate the error? Is what I'm saying. Aaron, what would you say?
It's the same kind of principle as an average. Like, why would you average to the center? Because if it's the average in the center, it means that that's the center of the here. So if you find the center of that, it's where it
Yeah.
needs to be. So if you have
What we are making an assumption actually, which you're kind of Liam suggested we're making an assumption. We are making an assumption. I think like you're saying, we're assuming that even within the group that the data is spread out evenly, yeah? So if we took the top end, we're assuming everything's at the top end. But actually, some of the data might be right at the bottom end. So you're as far away from that data as you could ever possibly be. But if I take the middle value, we're assuming some values are below and some values are above, and they cancel each other out, the difference. So we're kind of hoping, because we don't actually know, but the best we can do. So what we actually do for the mean, what we do is we do the sum of the midpoints. Okay? That makes sense, right? So how do we do it? Let's. I'm not giving myself much space here, but you've got this in front of you. So what do we do? So I'm going to do, to work out the estimated mean, the first group, 1.2 to 1.3, I'm going to assume that the numbers are all 1.25. So everyone in that group is 1.25. How many of them are there? 4. So I need to add up 4 lots of 1.25. How do you do that? Multiply. 1.25 multiplied by 4. 4 lots of that. Then the next group is going to be 1.35, and I have 6 lots of those. Then I have 1.45, and I have 8 lots of those. 1.55, and I have 6 of them. And 1.65, I have 6 of them. Right, so if you work all those out for me, if you've got calculators, good. So we've multiplied, we've just added them up. That's basically what we've just done there. Don't forget, that's just adding up all the numbers. That's adding up 30 different numbers. It just so happens that 4 of them were all 1.25, 6 of them were all 1. But it is just adding all the numbers up together. So when we add all those numbers, we end up with 43.9. Right? We then have to divide by the sum of the frequency, which is 30. And what do you get? 1.64.
1.46.
46. Should I just do 46 then? Why would I choose to just do 46 instead? Measured in centimetres. My data that I've been given is actually to the nearest 10 centimetres. Doesn't mean I would round that to 1.5. I can go, but having 1.463, it's not really relevant, is it? So my average height is 1.46. Average. My mean height is 1.46. Wow, I've just spotted a real issue with this data. Anyone spot it? Liam?
The mean is not the real number.
No, that's not the issue. I'm literally, that's fine. I'm quite happy with that number. There's one thing.
Really small.
They're really small, right?
Very
Anyone
small.
spotted that? I was just thinking, what are the units? It's obviously 1.46 meters. That makes sense, right? But did you notice in the table, centimeters? People are 1.46 centimeters tall.
Finally, my people.
Your people. So these shouldn't be decimals. They should be 120. But you know, bit of a slip up in the book there. What is the check that we should do? How do I know if I'm wrong, definitely? Yeah? I'm asking for definite wrong, not could be wrong. Check.
If it doesn't fit in any class interval.
Yeah, if it's smaller than 1.2 or larger than 1.7, I'm wrong. I've done something wrong. Just remember, what does a mean tell me? What should it do? Anaya? So it should represent the data set, yeah? If it's a number that's not even in the data set, how can it represent the data set? That's like me saying, oh, as a class, your mean test score is 1, even though the lowest score in the group was 5. You know? That doesn't make any sense, yeah? So anyway, that is the mean. Just remind me again, this estimated, why is it an estimate, Owen? So we're not using the actual numbers. And to be honest, you might get asked, why is this an estimated mean in a test? Yeah? And you need to be able to answer, because I don't know what the actual value is. You haven't been given the actual. You've not been given the what data? Raw data. Right? No raw data there, the data's already been grouped. So from that we can find the modal class, we can find the median, where it is, and we can find the estimate of the mean. All right with that? Okay, I'm done.